Okay, well, we have reached Friday, the end of the week. You guys get yourself a 3-day weekend. 2 weeks from today is the end of the 6 weeks, so we have a lot of really important grades coming up. You got the homework assignment yesterday. Once we finish this up, we'll just go ahead and start looking at a few together. I'll give you time in class to work on it, but the assignment's due Tuesday. You got the exam on Thursday that's going to cover trig equations. Most of it is multiple choice. I did put a few free response on there, but the majority is definitely multiple choice. And then one other thing I found out yesterday, the fourth 6 weeks, we were told by the home office that the district assessment was optional. We didn't have to do one. Well, now they're telling us the fifth 6 weeks we have to do it. So the last week of the 6 weeks, we'll just need to go ahead and take a day to get that done. It's not going to be a big deal. No, by district policy, they just want us to look at the data. We can't take it for a grade anymore. Yeah. Oh, she's laughing. Also, one other thing you may or may not have already heard, you're going to be getting out of school today 5 minutes early. And during 8th period, there's a fire drill. So it's going to be one of those at 3:50, Mr. Anderson will come on, say we're about to have our fire drill. He'll ring the alarm, and then you'll just take all your stuff with you, and you'll just keep going. I got to tell you, I miss the Fridays. The half-day Fridays, that was really nice.
Friday fun day.
Yeah. And for a while there, we were okay because the state legislature said that we had so many days that we had to meet, and even though it was a half day, it was still considered a full day. It's when they changed the requirement to so many minutes per 2 weeks, that's where we got caught. Yeah. So we had to switch that up. Okay, so let's go ahead. We have our second focus activity here. And this one is also a review. It's going to be over the double angle identity, so we'll talk about those in just a second. But once we get this done, we'll start working on the assignment, and that's what we got for today. All right, so let's go ahead and list out these identities. So it has been a while. Let's start with sine of 2 theta. Does anybody remember the formula of the identity for sine of 2 theta? It was a single expression. 2 sine cosine, that is absolutely right. So 2 sine of theta, cosine theta, then cosine of 2 theta. Now remember, this is the one that had 3 possibilities. Hello. Okay. So the first one was a variation on a Pythagorean triple, cosine squared of theta minus sine squared of theta. Or there were 2 others. Does anybody remember one of the other 2?
2 cosine, right?
2 cosine.
Minus 1.
Yes, there's just one thing you're missing. Cosine squared. There we go. So 2 cosine squared of theta minus 1 equals...
There's also 2 sine squared plus 1, right?
You're close. One of them just needs to be negative.
Negative 2 sine.
There we go. So we'll say 1 minus 2 sine squared of theta. Okay. All right. And then, of course, we have the tangent of 2 theta equals. Okay. So remember up top, we were going to have 2 tangent of theta. Does anybody remember what we put down below? Oh, it is tangent squared. Oh, well, one of them's negative, but there we go. So 1 minus tangent squared of theta. We were very close, yes. Okay. So remember, those were my formulas. Okay. So let's come on back up here to the problem. And it says, okay, we're given sine of theta is equal to 1/3. So I'm going to draw this coordinate plane right here. Now it says theta is in quadrant 1. So I'm going to draw a terminal side here. Let's say that's theta. Connect it to the x-axis. Now, what ratio does sine have? It's always y over r. So this is y, this is r. So the height here is 1, the radius is 3. Well, how do I figure out the x? Pythagorean theorem. That's exactly right. So let's see here. That would be x squared plus 1 squared is equal to 3 squared. Okay. So x squared plus 1 is equal to 9. And then what would x squared equal? Okay, 8. And then we have to take the square root. Good. Now, 8 is a composite number, which means we can go ahead and simplify it. What's equivalent to the square root of 8 if I were to simplify the radical? It is 2 square root of 2. Very good. Because we can rewrite the 8 as 4 times 2. And see, we can take the square root of 4, but this 2 has to stay inside. So we get 2 square root of 2. Okay, good. Okay. First time, is everybody okay with how I got the triangle? Okay. Now, using that triangle, we can go ahead and get my 3 trig functions. Now, sine of theta is already given to me. I know sine of theta equals 1/3. Okay. Cosine of theta, what does that equal? X over r. So the x we found 2 square roots of 2 over 3 over that radius. So yeah, I'm just using the ratio, getting cosine, and we'll do the same thing for tangent. So tangent of theta, that's y over x. So 1 over 2 square root of 2. And then let's rationalize. What does that mean, rationalize? You're right. Now you're going to multiply by, but what? Square root of 2. There we go. So square root of 2, square root of 2. So 1 times the square root of 2 is the square root of 2 over, that would be in 4, yes. Because the square root of 2 times square root of 2 is 2 times the 2 is where the 4 comes from. Okay. And here's the thing. When you're asked to find, like, for example, sine of 2 theta, it's just a formula. You're just going to plug those fractions that we have into the appropriate place. So, for example, sine of 2 theta. Okay. It equals 2 times, well, for sine of theta, we were given 1/3. Times, for cosine of theta, we found 2 square root of 2 over 3. And then from here, remember, the algebra just takes over. You just go ahead and multiply those. How do I multiply fractions anyway? Yeah, so let me make this a 2 over 1. Okay, so let's see here. 2 times 1 times 2 square root of 2. Okay, so that would be 4 square roots of 2 over 9. 1 times 3 times 3. There we go. So 4 square roots of 2 over 9. Okay. Now, cosine of 2 theta, we can choose to use any of those 3 formulas we want. Okay, let's just go ahead and use the first one here. So cosine squared, let me go ahead and write this out again. Cosine squared of theta minus sine squared of theta. Well, cosine is 2 square root of 2 over 3, right? And then I'm going to square it because I'm squaring the trig function. Minus, well, what am I going to plug in for sine squared? Oh, now remember that sine of 2 theta, we're just plugging in sine of just the 1/3 squared. There we go. Okay. So let's kind of work this out real fast. I'm going to square each of these terms inside the fraction. So what's a 2 squared? 4. Now what happens if I square a square root? It cancels it, so that would remain a 2. And then that's going to be over 3 squared. 9. So I would say when you square that, we're getting 8/9. Is everybody okay? Okay. Minus. Now I want to square 1/3. So let's see. 1/3 times 1/3? 1/9. And luckily we already have a common denominator. So it should be 7/9. There we go. Now for tangent of 2 theta, we actually have a choice. We have a formula that we could go ahead and plug in for. The one right down here. Or remember, we could use an identity. The idea that tangent of 2 theta would be sine of 2 theta divided by cosine of 2 theta. So you'd rather use the identity than the formula? Sounds like a plan. Okay, he's absolutely right. So sine of 2 theta, we already have that answer. That was 4 square root of 2 over 9. So 4 square root of 2 over 9. And I'm going to divide it by cosine of 2 theta, which we just found to be 7/9. But what happens when you divide by a fraction? Okay, so let's see. 4 square root of 2 over 9 times 9/7. And what happens here? 9's cancel, so it looks like tangent of 2 theta should be 4 square roots of 2 over 7. There we go. Okay, questions? Okay. Did anybody want to plug in the formula to see if we get the same thing? You did? Okay, let's do it. Let's see here. Now, tangent of theta was, remember, square root of 2 over 4. So we're going to plug into this formula here. So 2 tangent of theta over 1 minus tangent squared of theta. So each of these tangents right here, I'm just going to replace it with square root of 2 over 4. So 2 times the square root of 2 over 4 divided by 1 minus the square root of 2 over 4 squared. Okay, so let's see here. If I were to go ahead and multiply the square root of 2 over 4 times 2, okay, 2 square root of 2 over 4, so those would reduce, right? So that'd be square root of 2 over 2. And let's see here. Let me go ahead and simplify this. So that'd be square root of 2 over 2 over 1 minus, well, square root of 2 squared would be 2 over 4 squared. Oh, 16. So I'd be subtracting 1/8. Is that okay? Because 2/16 just reduces to 1/8. Okay. And now let's see, if I were to combine those two right there, the 1 minus the 1/8, what's your common denominator? It's got to be 8. So this 1, I'm just going to change it to 8 over 8. Okay. So this is going to give me 2, it's going to be square root of 2 over 2 divided by 7/8. And remember, we divide by a fraction, we multiply by the reciprocal. So I need a little more room here. Okay. That was weird. So square root of 2 over 2 times 8 over 7. And let's see, the 2 and the 8 can reduce. That's 1, that's 4. And when I multiply straight across, I do get 4 square roots of 2 over 7, which is what we got when we divided the two previous answers. Math. Questions? Anybody having a hard time? Do you guys remember that? It's been a while since we looked at the double angles. Okay. All right. Well, good, good, good. Go ahead and put that someplace safe. I've got 2 more focus activities that I'm going to be giving you over the next couple of weeks. All right. What I want to do now is take a look at the assignment. Okay. And remember, there were 8 problems that you did not have to work. Numbers 7 through 12, 24, and 26. You can go ahead and cross those out. Okay, I'm not going to have you work those. And I believe yesterday we did number 5. Okay. So why don't we go ahead and do a couple more problems together? Yes. So which problem would you guys like? And if you do need a copy, there should be some right over there in the filing system by Christian. Okay. Do I have the word for that? Should still be up here. I don't think I erased it. Yeah, here we go, right here. Yes, so looks like maybe I did erase. No, I think I did it on the. Oh no, I did erase it. Yeah, I'm sorry, because this is where we started, and I think I finished on the unit circle. Okay. So let me see. Where's my key? Anybody want to go ahead and remind me what answers we finally got for 5? We got pi over 3. 2 pi over 3. We got 7 pi over 3? We, we did? Wait a minute. That's not what's on this key right here.
Did you keep this wrong?
I don't think so. Because I solved it yesterday. Well, you know, everybody has a bad day. I'll tell you what, then we'll go ahead and change it real fast. I'm glad you asked because according to this, it should be 4 pi over 3 and 5 pi over 3. You sure we got 7 and 8?
Yeah.
We did?
Yeah, I even wrote it on my hand and everything.
You wrote it on your hand? Then that has to be my fault. I must have done something wrong. That's my bad. Okay. Sorry about that. I know. It's like your whole world is shattered now. You know, Mr. West can make a mistake. I mean, that's never happened. Why are we laughing? I don't understand. Okay. All right. So I'll promise from now on the other ones I will try not to make a mistake.
It was 7 through 12.
Yes, 7 through 12, 24, and 26. You don't have to work those 8. Okay. All right. So what problems would you like to look at? You want some water? Yeah, go for it. Okay. 16. Okay. Let's take a look at 16. Okay, actually, I'm glad you brought this up. For numbers 13 through 16, these here, what you're going to do, these are the ones you're going to use on the calculator, and I was meaning to go ahead and show you these. These you don't have to do any work because the calculator is going to go ahead and do these for us. These are examples of ones like we did the other day where we got a decimal answer. Okay, so what I would do is if it's not already set equal to 0, I would probably go ahead and do that. Because when you plug it in your calculator, you can go ahead and figure out where it crosses the x-axis. That's where the function is going to equal 0. So in this case right here, on number 16, I just want one side of it to equal 0, and it doesn't matter which one. Would you like me to move the x squared to the right or x and the other term to the left? Well, what would you guys prefer? Yes. Move the x squared to the right? Okay. So if I'm going to do that, I'm going to subtract it from both sides. Okay. Those are going to cancel. So there's your 0 equals negative x squared plus x plus 3 cosine of 2x. Okay. So now what we can do is just plug it in the calculator, and because it's equal to 0, we can find where it crosses the x-axis. Okay. So I'm going to come on over here to my calculator. Negative x squared plus x. Let me just see here. So I'm going to go to my graphing screen. Negative x squared plus x. And then what was it? Plus 3 cosine 2x. Plus 3 cosine of 2x. Okay. All right. And see, then it's going to give me a very unusual graph. But you'll notice how many answers should I have? 2, because it's crossing in 2 locations. So there's a variety of ways you could find those. What I would do is probably go to menu, okay, analyze graph, and I'd look for the 0. You know, we set it equal to 0, so we want to find the roots of this guy. I'll get you a off of it. So it'll say lower bound. Let me show you what you do with that. Hey, come on in, man. All right. So let's say we want to find this one on the left first. So it looks like something less than -1. Well, when it says lower bound, it's asking you to put that vertical line to the left of the point you're trying to find. So I want this point right here. So let's say, and actually you can put it way over here if you want to. The distance doesn't matter, but I usually like to put it just to the left of it. We'll push enter. It'll lock it in place, and you'll notice it now says what? Upper bound. So if lower bound is the left side, upper bound is the right side. So as soon as I sweep it across, see, it provides me a shadow region, and as soon as it hits that point, it'll automatically give me what I need. So I know one solution to that equation is negative 0.616. Okay. So I know x is equal to a negative 0.616. Okay. Now I want to go ahead and find the other one. And I'll do it the exact same way. So I'm going to go to Menu, Analyze the Graph. We want the 0. But this time, because I want this one, I'm just going to put it midway to the left of the point I want. Click Enter, upper bound, sweep it to the right. Okay. So that should be my other answer, 0.811. Okay. I mean, if you rounded it to 2, I'd be fine with that. Okay, so if you want me to say 0.81, there you go. So that is what you would do on those 4. In fact, I would probably encourage you start with those because you'll need a calculator in order to solve them. Okay. And numbers 13 and 14 are already set equal to 0. On 15, I would probably go ahead and subtract the x over and then go ahead and plug it in. Okay. All right, good, 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 good. What else? Like from each section?
Yeah, you know what I mean? Like,
Okay.
how we did number 5 through 1 through 6. How we just tell them.
Oh, so you just want to take like one per section and kind of work it? Oh, yeah, we can do that. Okay. All right, so in this first section here, it only goes through 6, so we already did 5. Which other one would you like? 1, 2, 3, 4, or 6? You want to do 6? 4. Okay, let's do 4. Okay, now this one, we don't have to do anything fancy. It's just a single trig function. So all I want to do is rewrite this so that it says cotangent equals. I just want to get everything to the other side. This is just your standard equation. So how would I do that? Okay, let's subtract 1. So minus 1. Those are going to cancel. So square root of 3 cotangent of theta equals negative 1. And now what? Okay, now divide by square root of 3. So we have that cotangent of theta equals negative 1 over the square root of 3. Now, the one thing I have noticed, we absolutely could rationalize if we wanted to, but a lot of people tend to want to work with sine, cosine, and tangent because those are the ones that we're the most familiar with. So instead of rationalizing, well, what if we just took the reciprocal? What's the reciprocal of cotangent? So if I were to say tangent of theta equals the negative square root of 3, and see, we don't have to rationalize at all. All I did was just take the reciprocal. But could we have solved it with cotangent? Absolutely, and we're going to get the exact same answer. Okay, but I thought maybe that would be easier. Now here's the thing. What is tangent's ratio? Y over x. So I want to measure all those locations where I can take a y value divided by its x value, and I get a negative square root of 3. So let's kind of narrow down the field here. What we're trying to solve is tangent of theta equals negative square root of 3. Where is tangent positive? First and third. But we're looking for a negative tangent, right? So that means we don't want to look in the first or the third quadrant. So my answers have to be coming from this right here.
Yeah, it would be 5 pi over 6 pi over 6.
Okay, well, let's check it just to make sure. Remember, tangent says y over x. So if it is...
I lied. 2 pi over 3. 2 pi over 3. No. Yeah.
You sure you want me to change that one?
Yeah.
Okay, so we'll check this one. We want to be able to take the y value divided by the x and get that negative square root of 3. Well, let's see. Square root of 3 over 2, that's the y, divided by negative 1/2. Well, when we divide by a fraction, we multiply by its reciprocal. And what's going to happen? The 2's will cancel, and we do indeed get negative square root of 3. Okay. So for like this type of problem, you only have to do it once, because once you know, I know that 2 pi over 3 is an answer, I can now take this line, and I can just follow it straight across to the other answer. Okay. So it should be 2 pi over 3 and 5 pi over 3. Okay. And that's a 5. Okay. Is that good? Okay. All right. So I said we don't have to worry about numbers 7 through 12, so that page is out. I already showed you how to do 13 through 16. Okay, and we did one of those. Looks like we got 17, 18, basically through the end, except for 24 and 26. So which one would you like to do out of that last section? Yes. Is it an emergency? Passes right over there. Okay, so which one are we thinking? Now we're looking at 17 through the remainder, but remember we don't have to do numbers 24 or 26. You want to do 25? Does that look like a good one, guys? Okay, let's do it. Now you'll notice this one is a quadratic and it's a trinomial, so think back to the other day. If it's a quadratic trinomial, we're going to factor it just like a quadratic. But let's go ahead and start. I can't remember the other day. Did you guys like replacing the trig function with a variable, or did you just want to keep the trig function? I want to say you guys replaced it. Is that what you replaced it? Okay. So let's just say that x equals cosine of theta. So 2 cosine squared would just be 2x squared minus 7 cosine minus 7x minus 4 is equal to 0. Okay. And now let's factor the quadratic. What would I multiply the 2 by? Okay. So multiply the first and the last. So that gives me a negative 8. Now the factors I'm looking for, I know one's negative, one's positive, but they have to add to give me a negative 7. What do we think? Okay. It's got to be negative 8 and 1. Okay. So remember, what we're using is the my father method. What would I do now? We would divide. Divide by 2. Always divide by the leading coefficient. So by 2, by 2. And the one trick here, we have to leave these as a fraction. So negative 8 halves, I would say negative 4 over 1. And then 1 half stays the same. So would this be negative 4x plus 1 or 1x minus 4? 1x minus 4. Okay. So this would be x minus 4. Actually, I'll just go ahead and write this over here now. X minus 4 times. And what would 1 half be? 2x plus 1. Okay. See, now that I have it factored, all we want to go ahead and do is replace x with what? Yeah, just replace it back with cosine. So x minus 4 would actually be cosine of x minus 4. Okay. Times 2x becomes 2 cosine of x plus 1 is equal to 0. And this is looking familiar. There's some property I want to use. The zero product property. So what does that mean for each of these two terms? There you go. Either cosine of x minus 4 equals 0, or 2 cosine of x plus 1 equals 0. Okay. Now, if I were to add the 4, let's go ahead and isolate these. So those cancel. So cosine of x is equal to 4. Or over here, if I subtract the 1, 2 cosine of x equals negative 1. Divide through. So cosine of x equals negative 1 half. Okay. All right. Does anybody have questions about how I got here? Everybody's okay. right? Now this one, because it's cosine, we're just looking for x. Specifically, where is x a negative 1/2? So if I come back here to my unit circle, where are those locations? Okay, 4 pi over 3, there is a negative 1/2 for the x, and a 2 pi over 3. There we go. So far I've got 2 pi over 3 and 4 pi over 3. Come back over here. So theta, and of course I let x, but theta x, that doesn't matter. 2 pi over 3, 4 pi over 3. Okay. Now cosine of x is equal to 4. Why is that undefined? Wait. That's exactly right. Think about your unit circle. Okay. What's the farthest any point can be from the center? 1. So there is no location where I'm going to be 4 units away. So this one here, you're absolutely right. That one's not going to give me an answer. Even if I were to plug it into the calculator, if I took the cosine inverse of 4, okay. And let's see here. Let's go back to my calculate screen. Cosine inverse. Oh, interesting. See, if I go ahead and take cosine inverse of 4, if I try to plug it in, it's going to give me an error message. 4 doesn't belong to that interval we talked about with the inverses. So this one, number 25, only has 2 answers. There we go. Perfect, perfect, perfect. How we doing? Okay. And I will go ahead and give you a hint on some of these. Like, look at number 20. Let me go ahead and show you number 20 here. Okay. It says cosine theta plus sine theta is equal to 0. Well, this one, you could actually go ahead and use this trick on numbers 21 and 22 as well. Because, you see, there's no identity I can use. There's no way, even if I isolate one trig function, it's going to equal the other trig function. So here's what you can do. If you have 2 different trig functions and there's just nothing to work on, just move one over. So set one equal to the other. Okay. And then what you can do is go ahead and just what? Anybody think they know? Oh. Oh, okay. It happens. Oh, I'm just waiting to see if it went. What I would do is divide by a trig function, because if you have one trig function equals to a second trig function, you can rewrite this so that a trig function equals a number. Okay. Let me show you what I mean. What if I were to divide by, oh, let's say sine? Cosine over sine is cotangent of theta, and that equals -1. See, now you've got one trig function equals to a number. We can solve that easily. In fact, even if you didn't want to use cotangent, I heard somebody say it, what if you did divide through by cosine? Then it would be tangent equals -1. Okay. And see, then you're just looking on the unit circle, where does tangent of theta equal -1? Does that make sense? Okay. So numbers 21 and 22 can be done very similar, or using something very simple. Okay. Okay. All right. Well, good. I think we got away with several problems today. Good, good, good. Okay, so remember, when's this due? Tuesday. So we'll come in, we'll grade it, we'll talk about a few more, and then we'll go ahead and start the next unit. We're going to start what's called vectors.
So, divided by sine, wouldn't it be a... Oh, never mind. I got you.
Or do you want me to show you dividing by, say, cosine?
No, it's fine.
Okay. All right.